Hello, my dear friends. How are you all? I hope you all are awesome. So, friends, you are very welcome in our lecture number 2. So, friends, today we will discuss the another topic, okay, related to the real numbers. Okay, so previous lecture you will learn about the introduction to the real numbers. Now, in this lecture, we will see the another topic which is very interesting and very important. Okay, which is very interesting and very important topic. Okay, so without wasting the time, let's start. Yes. Today we will discuss Euclid's division lemma. This is a theorem which is very important. Okay. Yes. So, friend, Euclid's division lemma. In this lecture, we will see, okay, a statement of Euclid's division lemma. So, the statement of Euclid's division lemma is that it states that given positive integers, okay, let's suppose we have a two positive integers like a and b. Okay, so given positive integers a and b, there exists a unique integer q and r which satisfying this relation, which satisfying, yes, what relation? Yes, this relation. Okay, so what relation says that a is equals to bq plus r, where r having the value greater than equals to 0 but less than b. Okay, so Euclid's division lemma states that given two integers a and b, there exists a unique pair of integer q and r, so that a is equals to bq plus r, where r having the value which is greater than and equals to 0 but less than b. Okay, so this lemma is essentially equivalent to what? Yeah, I will write here. This lemma is essentially equals to dividend equals to divisor into quotient, okay, plus remainder. Okay, so dividend is equals to divisor plus quotient, divisor into quotient plus remainder. Okay, I hope you got this point. Now we compare this equation from this equation. Here a is equals to bq plus r. Okay, so now what is a? A is our dividend. What is b? B is our divisor. And what is q? Q is our quotient. And what is r? R is our remainder. So I hope you got this point. Dividend is equals to divisor into quotient plus remainder. Let's suppose we have an example like 3 upon 2. Now if we divide 3 by 2, we can write here 3 is the dividend which is come under this part. Okay, and 2 is our divisor, we can write here 2. Okay, now 2 ones are 2, we got the remainder is 1. So if we verify this relation, if we verify this relation, here you have to see that 3 is equals to what is b? B is our 2. What is q? Q is our 1. Q is our 1. And what is our remainder? Our remainder is same as 1. Okay, so now If we solve it, 2 into 1, 2 plus 1, 3. Okay. So LHS is equals to RHS. Done. Now here the statement is states that, which is the very important part, is that we have Q and R of unique integers. Let's see here. Here Q is 1 and R is 1, which is unique. Okay, which is unique. And now what is our next condition? Yeah, R must be greater than and equals to 0. Yeah, of course, R is having 1, which is greater than equals to, which is greater than to 0. And but which also less than B. And what is our B? Yes, 2. And 1 is also less than B. So which is satisfying and which is verifying the relation, this, which is verifying the relation. A is equals to BQ plus R. So I hope you got this point. Okay. Now we are talking about lemma and algorithm. Euclid's division algorithm is also comes in the next slides. So what is the difference between lemma and algorithm? Okay. Yeah, this lemma. We are talking about this lemma. Okay. Yes. So guys, a lemma is a proven statement used for proving another statement. Means this statement is already a proven statement. Okay. And we use this statement to prove the another statement. So this is the meaning of lemma. So here is the lemma, is saying that this statement is already proved. Okay, we no need to be proved this statement. Okay, and by using this statement, we have to prove the another statement, another theorem. So I hope you understand this part. What is the meaning of lemma? So what is the definition of lemma? A lemma is a proven statement, okay, used for proving another statement. I hope you got this point. Now comes on algorithm. What is algorithm? Okay, so an algorithm is a series. Okay, algorithm is a series of well-defined steps which gives a procedure, for solving a type of problem. So what is he states that an algorithm is a series. Algorithm is a series in a well-defined steps which gives a procedure for solving a type of problems. Okay, so I hope you understand this point. So now we will move on. Yes, here comes is that Euclid's division algorithm. Means algorithm is what? Algorithm is a series like A plus B plus C plus D. Okay, this is also called a series. Yeah, like this we have to use this algorithm series in the Euclid's division. So Euclid's division algorithm is a method. Euclid's division algorithm. Yes, Euclid's division algorithm is a method. What method? Which is used to find the HCF of two numbers like A and B. Like we have two numbers. What numbers? A and B. Okay. So we have to find the HCF of A and B by using Euclid's division algorithm, which having a following steps. Okay. So now here is very important note is that between between these two integers a and b, a must always greater than b. Okay, okay, a must always greater than b, not equal, not less than, must greater than. Okay, I hope you got this point. So now we apply Euclid's division lemma to find two integers. Okay, we apply Euclid's division lemma to find the integers q and r. Now we have to find the integers, means quotient and remainder. Okay, by using this, a is equals to bq plus r. Okay, I hope you got this point. Yes. Okay, so if, here is very important note, if r is equals to 0, if r becomes 0, then r HCF, then r HCF what? Then HCF of a comma b is equals to what? Yes, is equals to the divisor. What divisor? Yeah, here is the divisor is b. So r HCF is b. If another condition is that if r is not equals to 0, if r is not equals to 0, then in that case, here in that case, a is our dividend and b is our quotient. Okay, oh sorry, b is our divisor. Now if r is not equals to 0, then b becomes the divisor or dividend and r becomes the divisor. Okay, and here by using b and r, we got another quotient and another remainder. Okay, so now we repeat these steps again and again until and unless we got our remainder becomes 0. We got our remainder is equals to 0. I hope you got this point. So this is our Euclid's division algorithm. If here r1 becomes 0, then what is HCF? Yeah, HCF is r. HCF is our r. Okay, okay, yes. So now, yes, okay, yes, I hope you got this point. So now we will move on. Now, yes. So the examples of Euclid's division algorithm is here. Okay. Yes. Our question number 1 is use Euclid's division algorithm. We have to find the HCF of 135 and 225. 135 and 225. Okay. So now in that case, first of all, we have to understand what those are numbers and which one is greater and which one is our greater number. If we see in 135 and 225, which one is greater? Yeah, of course 225 is greater. Okay, so now a is equals to 225, sorry, 220 and b is equals to 135. Okay, so as you can see from the question, 225 is greater than 135. So therefore, by Euclid's division algorithm, okay, what is the relation? A is equals to BQ plus R. Now here, what is A? Yes, 225 plus is equals to 135. Now if we divide 225 by 135, let's do that. 225 is divided by what? Yes, 135. Okay, now 225 is divided by 135, and here is a 1 and here is a 135. If we subtract, we got what? Yes, 90. So what is our question? Question is a 1. What is our remainder? Remainder is our 90. Now listen to me very carefully, guys. Here our remainder is not equals to 0. Our remainder is not equals to 0. So now in that case, our 135 is become dividend, means 135 is become A, and B, what is B? Yeah, 90 becomes a B, means divisor. Now again we divide 135 by 90 to obtain quotient and remainder. Now again it goes to 1 times 90 and we got remainder 45. Okay, now what is our question? Yeah, question 1 plus remainder is 45. Now again our remainder is not equals to 0. So now again we repeat these steps again. So these steps are called algorithm. Okay, so these steps are called algorithm, which is well planned steps, well organized steps. Okay, so now here 90 becomes A, 45 becomes B. Now again we divide 90 by 45. Oh yeah, it goes to 2 times. Now here the remainder is 0. Okay, now quotient is 2 plus remainder is 0. Now here we got the remainder is 0. So what is the HCF? So now HCF is 45. Very good. So HCF of 135 and 225 is equal to 45. Okay, that is our result. I hope you got this point. So guys, this is our quotient. Okay, so the remainder is now 0 and our result is 45. Now another question is that we have to find the HCF of 196 and 38220. So which one is greater? This is our A and this is our B. So by Euclid's division algorithm, A is equals to BQ plus R. Okay, so now 38220 is equals to 196. If we divide 38220, it goes 195 times, plus remainder becomes 0. Okay, so now here remainder is equals to 0, and so our new HCF, our HCF is 196. This is a 6. Okay, this is our 6. Okay, yes. So HCF 196 and 38220 is equals to 196. Okay. So this is our answer. Yes, okay. Now we will move on our next question. Yes. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 and or where q is some integer. Now we have, yes, odd integers 6q plus 1, 6q plus 3 and 6q plus 5. We have to prove that these numbers are odd integers. Okay, so first of all guys, let be any positive integers a and b. Let a is any positive integers, positive integer. Okay, and b is equals to 6. How b is equals to 6? I will tell you. Because if you see that 6q plus 1, 6q plus 3 and 6q plus 5, here 6 is a common, so b is equals to 6. If we compare a is equals to bq plus r, here b is what? Which is which is 6. Okay, so I hope you got this point. Now, so by Euclid's division algorithm, okay, a is equals to bq plus 6, bq plus r. Now, what is r? A is equals to bq plus r. Now, what is r? Now, r is always greater than and equals to 0, but less than what? But less than b. Okay, so now, what is b? B is 6. So, r is always greater than and equals to 0, but less than 6. So, what is the value of r? So r having a value 0, 1, 2, 3, 4, 5. Okay, till 5. Okay, now we substitute the value of r in this equation. Okay, so first case is the r is equals to 0. So a is equals to 6q plus 0. It become 6q. Okay, now r is equals to 1, a is equals to 6q, a is equals to 6q plus 1. Okay, now again we put value of r is equals to 2. We got a is equals to 6q plus 2. Okay, and r is equals to 3. We got a is equals to 6q plus 3. If we take r is equals to 4, we got a is equals to 6q plus 4. Okay, and one last is, if r is equals to 5, we got a is equals to 6q plus 5. Okay, now, okay, so now if a is equals to 6q, if a is equals to 6q plus 2, 6q plus 4. Listen to me very carefully. A is a even number. Okay, because 6q plus 2 6 cube plus 4 can be divided by 2. So then A is an even. Okay, and which can be divided by A and divisible by A. Divisible by 2. Okay, so a positive integer can be either even or odd. Okay, therefore any positive odd integer is of the form. So any positive odd integer is of the form, listen to me very carefully, is that, so any positive odd integer is of the form 6 cube plus 1, okay, 6 cube plus 3, and finally 6 cube plus 5. Okay, where q is some integer. Q is some integer. Okay, yes. So 6 cube plus 1, 6 cube plus 3, and 6 cube plus 5 are odd positive integer. Okay, so hence proof. Okay, now we will move on. An army contingent of 616 members. An army contingent of 616 members is to march behind an army band of 32 members in a parade. Okay, the two groups are to march in same number of columns. The two groups are to march in the same number of columns. What is the number of columns in which they can march? So we have to find the maximum number of columns. Okay, so now before starting we have to write the given part. Okay, yes, we will write here. So now number of army contingent member is equals to members is equals to 616. Okay, and number of army band members, how many? Yes, 32. Okay, yes. So if the group having to march in same column, we have to find out the highest common factor. Between the two groups. So HCF of 616 and 32 gives the maximum number of columns in which they can march. Okay, I hope you got this point. So HCF of 616 and 32 gives the maximum number of columns in which they can march. So by Euclid's division algorithm, so by Euclid's division algorithm, we can find the HCF between 616 and 32. Listen to me very carefully. HCF, to finding the HCF, we have two methods. What? First is Euclid's division algorithm, and the second is prime factorization method, which we will be discussed in the next lecture. Okay, so now here 616 is greater than 32. So by Euclid's division algorithm, we can write 616 is equals to 32. 616 is dividend, 32 is a divisor, and if we divide, we got quotient what? 19. plus remainder is 8. Okay, and now our remainder is not equals to 0. So here So here 32 becomes the dividend and our remainder becomes the divisor 8. Now we divide, it goes to 4 times plus 0. Now r becomes 0. Now here at CF 616 and 32 is equals to what? Is equals to what? 8. So I hope you got this point. Yes, exactly. Yes. Okay. So our HCF is 8. So friends, the maximum number of columns in which they can match is 8. Okay. Now we will move on the next question. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, to solve this question, first of all, let x be any positive integers. So this question is same as like question number second, which is small bit similar. So now, the solution is that let x be any positive integer. Okay, and same y is equals to 3. Why? Because 3m or 3m plus 1, here 3 is our b. Okay, and here 3 is our divisor and y is equals to 3. Okay, so by Euclid's division algorithm we can write x is equals to 3q. X is equals to 3q plus r. And what is the value of r? The value of r is 0, 1, 2. Okay, not more than 2, because we have the value of b is 3 and r must be less than b. Okay, so now as per the question given, this we have to square both the side. Okay, so now we are putting the value of r step by step. Okay, so first, if r is equals to 0, x is equals to 3q. Okay, now we have to square both the side. So it will become x square is equals to 9q square. We can write this also 3 into 3q square. Okay, now please, you have to follow the instructions. You have to follow these steps, which is very important. Okay, you have to write in the exam same as these steps. Okay, so let 3q square is equals to m. Okay, now x square is equals to, so therefore x square is equals to what? 3m, and here is our first equation. Okay, now we will move on. Now again, if r is equals to 1, then x is equals to 3q plus 1. Okay, now again we square both the side, so it will become x square is equals to x square is equals to, now 3q plus 1 square is equals to a plus b b whole square. Okay, so now here it will become 3q whole square plus a square plus b square plus 2 into ab. So 3q square plus 2 square plus 2 into ab means 2 into 3q into 2. Okay, so our x square is equals to 9q square, okay, plus, here is not 2, here is 1. Here is our 1 because b is our 1. Okay, yes, here is 6q plus 1. Now we have to take the common from 9q square plus 6. Please listen to me very carefully. Here is a twist. Okay, yes, so from these two terms we can take the common. X square is equals to, what is that? We are taking 3 as a common, and it will become 3 square plus 3 square plus, wait, 3 square plus, yes, 2q. Okay, yes, now plus 1 is here is also, yes. Now let again 3q square plus 2q is equals to m. Okay, now we have to put in this equation. We got x square is equals to 3m plus 1. This is our second equation. Okay, so this is our second equation. Okay, now again r is equals to, now we put the value of r is equals to 2. Okay, so now what it will become? X square is equals to, wait a minute, x is equals to 3q plus 2. Now again square both the side, square both the side, it will become x square is equals to 3q square, 3q all square plus 2 square plus 2 into 3q into, what is, yes, 2. Now the value of x square is 9q square plus 4 plus what, plus 12q. Now we can write this also, 9q square, okay, plus 12q plus, we can write 4 as 3 plus 1. Okay, now we have to take the common from these three terms. Okay, so x square will become what? Yes, we take 3 as a common, and it will become 3q square plus 4q plus 1, and here is 1. Okay, so now let again what, 3q square plus 4q plus 1 is equals to 0. Oh, sorry. Plus 1 is equals to m. Plus 1 is equals to m. Now our x square becomes what? Yes, 3, okay, m plus 1. What it will become? Yes, this is our equation 3rd. Okay, so from equation 1, 2 and 3, what is our equation? Equation 1 is x square is equals to 3m. Okay, second equation is x square is equals to 3m plus 1, and our third equation is x square is equals to 3m plus 1. Okay, so we can say that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So here is this proof. Okay, now hence proof. So I hope you got this point. Now let's move on. If the HCF of 210 and 50 is expressible in the form of 210 into 5 plus 55y, find the value of y. Okay, so now friends, first of all we have to find the HCF of 210 and 55 by Euclid's division algorithm. After that, the value of that HCF will be equals to 210 into y plus 55y. Okay, yes. Now I'll start our question. Yes, by Euclid's division lemma, okay, 210 is greater than 55, so our A is 210 and our P is equals to 55. Okay, now so what is the relation? A is equals to BQ plus R, and here we put these values. Now 210 is equals to 55. Okay, now if we divide 210 by 55, we got Q is 3 plus we got remainder is 45. Okay, now our remainder is not equals to 0. Our remainder is not equals to 0. So in that case, again, in that case, 55 becomes the dividend and 45 becomes the divisor. Now if we divide 55 by 55 by 45, we got Q is 1 plus we got remainder is 10. Okay, now again R is not equals to 0. Now again 45 is equals to 10. Now if we divide, it will goes to 4 times plus remainder is 5. Now again remainder is not equals to 0. Now 10 becomes the dividend and 5 becomes the divisor, and it goes to 2 times. Now here remainder is 0. Now here remainder is 0. Now the HCF of 210 and 55 is equals to what? Yes, 5. I hope you got this point. Yes, we put in the block now. Okay, so the HCF according to question, our HCF is equals to means 5 is equals to 210 into 5 is equals to 55. Sorry, not equals to. Here is what? Plus 55y. Okay. Now, by solving this equation, we can find easily the value of y. So 5 is equals to, if we multiply this, we got 0, 5, 1, 0 plus 55y. Okay. So we shift the value of 1050 to the, yes, LHS. So 5 minus 1050 plus 50. Sorry, here is the sign of equal. Is equals to 55y. Okay. So if we minus 5 minus 1050, oh, 1050, it will become 1045 and is equals to 55y. Now 55y is in the multiplication of y. If we goes to it to the LHS, it will goes to the in denominator 1045 divided by 55. Okay, is equals to y. If we divide 1045 by 55, it goes to completely by 19 times, and the value of y is equals to minus 90. So this is our result. So the value of y is equals to minus 90. So here we are finishing our lecture. Okay. So now we will meet in our next lecture. Okay. So guys, thank you very much guys for listening me.